Hello. Okay, so we're just going to try some examples of how we do these, okay? And they're all essentially similar to ones we've done before, but I want to make sure that we're clear on what we're going to do and with kind of like the vocabulary. So one way that we might see this is it'll simply say find the antiderivative. Right. And it'll say, example A here, how about f of x is equal to 7? So that's the same as the indefinite integral 7 dx. Now you want to visualize what's the function that if we take the derivative we get 7. Well, that's going to be 7x and then plus c, because keep in mind that remember the reason why we need that plus c is you can visualize that if we had, say, 7x plus 1 or 7x minus 3 or 7x plus, I don't know, 100,000, or actually a million, right? Or how about 7x plus pi? Really doesn't matter. If we started with any one of these functions, right, and we took the derivative, all of them, the derivative would be 7, right? So therefore, when we're working backwards, we don't know which of these we mean, and there's no way to tell, of course, and so we add the plus c. So this is one look when we're taking an antiderivative, and when we're calculating this indefinite integral. We're not going to get a single number because we're not given these limits of integration. But what we get is like an entire family of functions, right? 7x plus c. Okay, so what if we had something like b? Okay, how about if we had something like this? T squared plus t dt, right? So first off, we're going to use our power function, and second of all, notice we've got two different functions really that are adding. So we're going to go t squared dt plus t dt, right? And keep in mind that's really got an exponent of 1, right? So we're going to work backwards here. Here we're using our power rule, right? So this is going to be, power rule looks like this, just to remind you. If we've got a x to the n, the power rule is a over n plus 1, x to the n plus 1. So this is going to be 1 over 2 plus 1, which is going to be 2 plus 1, right? T to the 2 plus 1. Right, which is going to be 1/3 t to the third power. Now you can see that works out fine because if we work backwards and take the derivative of this, we'd end up with just plain t squared. All right, and then here, this is now n is 1, so it's going to be plus 1 over 1 plus 1 t to the 1 plus 1, right? Where here the n, for both of these, the a number was 1. I hope you can see. So this is 1/2 t squared. And again, oh look, working backwards, the derivative of t of 1/2 t squared would just be plain t, right? T dt. Okay, so anyway, so here is, right there, oh, and then plus c, we only need one constant at the end. So plus c at the end, right? That's how we do that. Okay? All right, how about c? Let's try, how about, here's an interesting looking one. How about, and by the way, this one might just look like, I just noticed, it would just be written as this. What's the antiderivative? Well, we'd write it as that. So how about this one? Now, f of x is equal to, say, 5 over x. What's the antiderivative of that? Well, we're going to simplify this again using our antiderivative, using our derivative rules plus our integral concepts. Okay, this is going to be f of x, you understand, can be written 5 times 1 over x, right? Well, that's the integral of 5 times 1 over x dx. That's how we're going to do that. Well, we're going to take that 5, move it out to the front. I'm going to change colors here. Doing blue. 5, 1 over x dx, right? Well, what's the function that when we took the derivative of it, we got 1 over x? Well, remember that it was d dx of ln x gave us 1 over x dx, right? And so therefore, this is going to be equal to 5 times ln x plus c. All right, because the antiderivative of 1 over x is ln x times the 5 on the outside and plus c to give us our family of possible antiderivatives. Okay, so that's that. So that's a good one there. Okay, now also, I feel like we could do something like this, and it might fool you if you haven't really thought about it or seen it before. Let's say we're on D now. What if f of x was equal to negative 2x to the negative 1? Okay. Well, okay, what do we do about that? Can we use, we can't use the power rule of negative 1, right? Because if we add, if we try just adding 1, it crashes. So we just remember that we can write this f of x is equal to negative 2 times 1 over x, right? So that negative 1 there. So then backwards here, so that's going to be negative 2 times 1 over x dx, written as an integral, right? Negative 2 comes out front. 1 over x dx, which is just, and over here, negative 2 times ln x plus c. And that's our answer right there. Okay, so that's how that goes. Okay. How about E? What if we had f of x was equal to 3 cosine x, right? That's the antiderivative. Well, that's going to be 3 cosine x dx, which is equal to 3 on the outside, cosine x dx. And what's the function that if you take the derivative of it, you get cosine? Well, remember that d dx sine is equal to cosine x dx, right? All right, there we go. Okay, so therefore, this is equal to, I'll use red again for this one, 3 sine x plus c. Okay, so that's more or less how that goes, right? And so let's see if let's try something like this. Now, each one of these, instead of writing it as find the antiderivative, right, stating it like this, giving you a function and saying find the antiderivative, they might just give it in integral form. Either way, it's the same problem, just written a different way. So some of your homework problems, it'll be written like this, right? But you'll still be working backwards to find the antiderivative either way. Okay? Now let's see. you might have some kind of special applications of these, or, sort of nuances, you might say. You might have something that looks like this. Find the antiderivative of, so this is f. Find the antiderivative if, right, f of x is equal to 4, given that capital F of 0 is equal to 0. Okay? So given, in other words, that we happen to know that the antiderivative at 0 works out to be equal to 0. So we're given this initial condition, right? Well, the difference there is that we're going to be able to specify, because we have that initial condition, we're going to be able to specify one specific value. We won't have for the antiderivative. So we're going to write it like this. This is 4x, oopsie, rats. That's actually the antiderivative, getting ahead of myself. All right. 4 dx, and the antiderivative to that, I hope you're going to see, is 4x plus c. That's what capital F is equal to. F of x is equal to 4x plus c, right? Well, okay, you can see here it says that f of 0 is equal to 0. So I'm going to put 0 in, so f of 0 is going to be equal to 4 times 0 plus c, right? Well, f of 0 is equal to 0, which is equal to c. So c, under this specific initial condition, the c constant is equal to 0, so our antiderivative, f of x, is just equal to 4x. Okay? We don't have to put the c on the end because we nailed down that specific initial condition. Okay, so how about this one here? G, f of x is equal to sine x plus cosine x, right? Under the condition that f of 0 is equal to 0, right? So first we find the antiderivative, which is going to be sine x plus cosine x dx, which, using our characteristic of functions, of integrals, is going to be sine x dx plus cosine x dx separately, and f of 0 is equal to 0 for both of them, right? So what's the function that if you take the derivative of it, you get positive sine? Well, the derivative of cosine will equal to negative sine x dx, right? So if we start with positive sine, that's the antiderivative is going to be negative cosine, right? So this is going to be negative cosine x, and then the antiderivative of cosine is sine x, and plus c, so we can combine actually both constants into one, right? So this is f of x, the antiderivative, you understand. So we know that f of 0 is equal to 0, so this is going to be equal to 0 is equal to negative cosine 0 plus sine 0 plus c, right? Well, a cosine of 0 is 1, right? And so that's going to be negative 1. The sine of 0 is 0. plus c. So you can see that solves to us getting that the constant is equal to 1, right? So our final answer on this one, because we have this initial condition, f of x, the antiderivative is negative cosine x plus sine x plus 1. Okay. All right. So that's kind of how that goes. So I'm going to try one more of these. Okay. Try one more of these antiderivative type things. Okay. And what if, okay, that's G. Okay, so one more here. So this will be example H. Sorry, paper shuffling here. Okay. Example H. Let's say we've got negative 6 over x to the 4th power. Okay. Well, dx, right? So we're going to move the negative 6 to the outside, get 1 over x to the 4th dx. Well, remember how we handled that when we did derivatives. We wrote it as negative 6 x to the negative 4 dx, right? And remember, oh, by the way, forgot, f of 0 is going to be equal to 0 here, okay? All right, now we're going to go ahead and we are going to take the antiderivative. Okay, so remember this is going to be negative 6 times 1 over negative 4 plus 1 x to the negative 4 plus 1. It's just like, so that's our power rule there, plus c. So this is negative 6 times negative 1/3 x to the negative 3, right? You can see that if we start with this, just this bit here, take the derivative of it, we'll get that, right? Okay, and then plus c. Right, so that's the general antiderivative. Now we know that f of 0 is equal to 0, right? So we can simplify this, by the way, a little bit. That's negative 6 times negative 1/3, that's 2x to the negative 3 plus c, right? And f of 0 is equal to that. So f of 0 is equal to 2 times that, right? Well, that's equal to 2 over 0 cubed plus c. And you can say, oh, wait a minute. That's undefined, right? Now, if we had specified another value, another initial value, like f of 0 was equal to 1, then we could have put a 1 in here. If f of 0 happened to be equal to 1, then we'd put 1 underneath there, 2 over 1 cubed plus c, or rather, f of 1 is equal to 0. Still doesn't evaluate it if we put 0 in, right? If we put 1 in there, that is equal to 0. We're going to get c is equal to negative 2 when we finish solving for c there, right? But you can see here, this initial condition of f of 0 equal to 0 causes this function, this antiderivative, to be undefined. So remember, we could have, in some cases for functions for certain points, the antiderivative would be undefined, if like it was a corner point, or if there was a vertical asymptote, say. It was undefined at that point. Well, antiderivatives, integrals, can be undefined also in certain cases, given the initial condition, if the function is undefined at the initial condition that you specify. Now, if we don't specify an initial condition, we would just go ahead and write this general integral as our answer. Okay. All right, but for this specific case, we're just going to write doesn't exist. Right? Okay. So I think that's enough to get on with. I'm going to upload some practice problems on a worksheet for you guys to do, and then there'll be some homework in the book. It's going to be on page 292. All right. And then Wednesday, look for that final. Bye.